to count correctly. So, what should I count by here, Ashley?
You should count by fours.
On this one?
No, count by.
So what should my scale be? Ones. Yeah, I just want to count by ones because this goes from 0 to 8. I want to spread this out and use as much of this axis as possible. By the way, this is as much as a science lesson today as it is a math lesson. Mr. Mabry would expect these exact same things. Okay, so we're going to count by ones. Technically, for me, if you're graphing and you count by ones, I don't make you label each one because it represents one. But if you count by something else, you do need to. So here, what I'm going to do is I'm going to go 1, 2, 3, 4. That way, mark 5, 6, 7, 8. Actually, I'm just going to do that. Okay, and then I have my dependent. Okay, my dependent always goes on my y. And then I need to put in, think about what I want to count by there. What would I want to count by there? Hannah. What? Probably fours. And the reason I choose fours is because they're all multiples of 4. I want to make this easy on myself. I also need it to fit on the graph paper they gave me. Okay, so I would count by fours. 4, 8, 12, 16, 20, 36. Okay, so then I go into graph this, and I say, okay, this is 1, 4, this is 2, 8, this is 3, 12, and 8, 5, 6, 7, 8, 32. Okay? Actually, okay, so then what this said, and you probably didn't catch this part, is it said graph and title, let's see, give the graph a title and label the axis so it's clear what the variables could represent. So what they're asking for is, what could this in life be a graph of? Sophia. The graph of a growth of a flower. Wow, that is good. So our independent here would be our number of days, number of weeks, months, and this would be our measurement of our flower in centimeters or inches, something like that. Great, great one there. Gavin.
I did drops on the sink per second.
Drops out of the sink per second? Sure. So for every second, it gets 4 drops. That would be a really fast, that would be a lot. Yeah, that would be a very quick sink. Okay, that would work too. Ashton.
Like there's 1 cup of flour for each 4 cookies.
Okay, 1 cup of flour for each 4 cookies. Yes, very good. Okay, yes.
One of my graph ball.
Let's see.
4 football players.
4 football plays per ball.
Yeah.
So 4 people have to touch the ball per play.
No, like every football.
Yes.
They use football.
They use 4 balls.
4 football.
That would be a whole new game, wouldn't it, James? That would be cool. I think you could say, couldn't you say 4 touches per play? That 4 different players have to touch it?
4 for basketball.
For basketball?
Yeah.
Yeah.
4 passes.
Yeah, that would totally work. Okay, now let me use that one because I want to talk about the difference between some of you drew a line and some of you did not draw a line. We need to talk about when you can and when you can't. Okay? So let me tell you when you can and when you can't. You tell me what I'm doing. Okay, for James's, I cannot draw a line between my dots. For Sophia's, I can. Who knows when I can and when I can't? Gavin. Technically they're both constant. Eva?
Over a period of time or not?
Very good. It's called continuous data. Anything that's continuous, exactly like science, you can draw a line in between them. Okay? Which means that something is happening over time or it's continuing to happen. Yes. Okay, baking cookies could possibly be continuous because what if I only wanted, see, if you said this was cups, okay, can I use a half a cup? A fourth of a cup? A third of a cup? Yeah, I could, right? I could make miniature cookies. Now, it might be silly, but I think you could make that continuous. Okay? But James's could not be continuous because we said if you have a play where people have to pass the ball, you can't have a half a play. You know, the coach can't go run half a play. What? That's weird. Okay, so do you see the difference between the two? And either one is acceptable on this, but you just have to know the difference. Okay? All right. Could we write an equation for this? Who can write equation? Alex.
Y equals 4x.
Very good. Y equals 4x. We're going to talk a lot more about this in this topic because that comes from where? Where do we get that? Constant proportionality. Where can I see that in this example that's up here, Taylor? Where does it say it? So 4/1, there's your y over x again. Is there any place else you can see it? Chase? In the graph right here, it's 4/1. Okay, all of that's mega important to us. That's a big deal. Okay, all right, anything you don't understand on this before I keep going? Okay, so this slide is here just to review basically everything I just did with you. I basically just reviewed every single concept. So you've got your table, you've got your graph, it's showing you your equation. This constant of proportionality is 2. So everything I just reviewed, here it is in one slide. Okay? All right, I want to look at this one because I'm trying to pick ones I think you might struggle with a little bit. Okay, so this one says a salesperson earns 10% commission on sales of energy efficient appliances. Draw a graph to model this situation. Is the amount of the commission proportional to the amount of sales? How do you know? Okay, so do you guys understand what commission is? No. No, who can explain commission? Anna. It is part of your pay? Yes. Yes.
I like tips on wages.
Kind of like tips on a waitress, right?
Is it like whenever you sell something, you get 10% of selling?
Exactly. Okay. So if I sell something that's $100 and my commission is 10%, what's my little bonus? I'll get another $10. Okay. So that's good. A lot of places work on commission. One that really works on commission is the buckle. You been in the buckle before? Yes.
Wait, what is
And how pushy are they when you walk in there? Pushy, right? And you go to the dressing room and they bring you like 10 pairs of jeans. And then even if you're in there, you're like, I came in to buy a sweater. But look at these jeans. And they're always trying to push clothes on you because they work on. Well, they are, but they make the most money. No, a lot of times you get paid by the hour too. But there are jobs that work straight on commission. Real estate. Waitresses work on tips, but they usually get, like when I was a waitress, I made $2.13 an hour. So I got a very, yeah.
Not even new.
Because you're getting tips. Real estate, like it, let's say anybody's parents in real estate.
I know.
That's
selling houses.
Selling houses.
My friend's parents.
Yeah,
So they're paying
that's all
only
they
on
work on.
commission.
They
That's
only
it.
are on commission. That's it.
You get a
So if they don't,
lot.
so if they don't sell a house, they make nothing.
No money.
Okay, so what if they don't sell a house for 2 months?
They have no money.
They have no money for 2 months. Great.
Isn't the commission on like Best Buy whenever you buy a TV? People that talk to you and sell to you get like 1% of selling.
I don't know if Best Buy in real life works on commission. I don't know. I don't know which. I know that Buckle does. I don't know what other stores do, but there's lots of stores that do. Car salesmen, most of them work on commission too, which again is why they're always on commission. A lot of times jewelry. Yes, a lot of those are. Okay, so let's talk about this one. Now this one's pretty open-ended. So we have to figure out what we want to do for sales and commission. Sales is the X, Taylor, because commission comes second. You have to have your sales in order to figure out your commission. So whatever comes second is always going to be your dependent. It depends on that one. Okay, so would it make sense to count by ones here?
Yeah.
No.
No.
No. What should we count by? We're talking. Okay, what are we talking about here?
Oh, sales. Hundreds.
What are we? We're talking about what?
Energy efficient.
Yes. So how much are appliances? They're hundreds, right?
Appliances.
So it's appliances, microwaves, dishwashers,
Oh,
refrigerators.
those.
Yeah, those would be hundreds. So we would not want to count by ones. Okay, and we can do whatever we want. So let's count by something easy, and let's just count by hundreds, right? Because we can figure that out pretty easy. 300, 400.
Oh, it's so much.
It is a little bit. It's okay. Okay, and then think about this. If we're creating our table, here's our XY. If I sell 0, how much commission do I make? 0. And we just said we're going to count by 100. So if I sell $100, what do I make?
$10.
$10. Excuse me, so that's 10%. 200,
20.
300, 30. continuous data or not? Yes, because is it possible for me to sell $150? Yeah, or I could sell 150 and 23. There's always going to be a commission. I'm always going to make 10% off of that. So this will be continuous. Okay. What do I need to count by then? Because I made my table, now I know what to count by here. Tens. Tens would make sense.
Wait, that's not a lot of money. If you have something for like $300, you only get $30.
But how many times a week do you think you sell something?
Oh yeah.
Oh, yeah.
You make a lot of money.
All right, so now let's go ahead and graph it. So if I sell 0, I don't get anything. But if I sell $100, I get 10.
So we graph it.
We graph it. And then we just said the data is continuous.
So
And
you
so
make
we're
a
going to
line.
draw our line.
You know, I have no. I can't glide down that slide.
Slide down that slide. Oh, I just actually, technically, if we're going to start talking about slope, we'd be climbing up that slide.
I know, run it and then go
Up
back
it.
down.
Nope. You gotta read. You gotta read graphs left to right. That is only going up. Okay.
Let's try to-
Now, is this amount of commission proportionate
Yes.
to the sales? Yes. Now, let's say that I'm gonna get tricky on you. What if I added an hourly rate? What if I said you make $10 an hour plus commission?
No,
That would not be because
Because it would not go through 0, 0, right?
it goes through like
Very good. So there would be a plus something there. Very, very good. Okay, what would the equation be for this graph? This is tricky. This is tricky. Make sure you really think about it. Hayden. Good guess. I told you this was tricky. Tricky. Sophia?
y equals x divided by 10.
Okay, I agree. However, I want my constant out here 110. What? Oh, because remember, it's y over x, right? Y over x. So, okay, now that's the same thing, right? Okay, so that's really good. So this is either 110, because I make 110, or 0.1. Yeah, because hey, listen, this is big. This is huge. Because if I was going to figure out 10%, don't I multiply it by 0.1? Yeah, so either one. Those are both great. Good ones. Okay? All right. Last one I want to look at with you. Okay. Yeah. Well, we did one in the warm-up. We did a percentage one, and now I want to do a fun graph. One that's mixed up in there. Well, I adjust depending on what I want to do.
There's like an extra one.
Yeah, that's okay. All right, so this one says ice forms at 0 degrees Celsius. The surface temperature of the ice on an ice rink decreases 0.5 degrees Celsius every hour. Draw a graph to model the situation. Start when the surface of the ice temperature is 0. Okay, I want you to see what this graph is. You guys have been exposed to this before, where you have different quadrants of your graph. Most of the graphs that we've been looking at are all in quadrant 1. Okay. This is quadrant 2, quadrant 3, quadrant 4.
And I remember in the lines, it's like on the quadrant 1, they're both positive.
Yes.
And when you get like, and then they change to like one positive and one negative on quadrant 4.
This is positive and negative. Now let's think about why. Because hours are
Positive and the temperature's going to be negative.
and the temperature's going to be negative because the temperature is decreasing.
Yeah.
Okay. All right. Very good. Okay. So let's start with our table here. X is going to represent hours, and this is going to represent our temperature. So at time 0, what is the temperature of the ice? 0. It says 0 degrees Celsius. Okay. This says it's counting by hours. So at 1 hour, what is the temperature of the ice?
Negative 0.5.